Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed intramolecular aldol condensation and/or acid-catalyzed enolization and dehydration leading to aromatization of a bicyclic enone. Moving on to the next step. The starting material is 8A-methyl-3,4,8,8A tetrahydronaphthalene, an octalone, which is a bicyclic compound consisting of a cyclohexanone ring bearing an alpha-beta unsaturation, enone, fused to a cyclohexane ring, with a methyl group at the ring junction, C8A. Moving on to the next step. Under acidic conditions, this type of bicyclic enone undergoes acid-catalyzed isomerization. The key process here is the acid-catalyzed tautomerization dehydration sequence. The enone system in ring A, the cyclohexane, can undergo repeated enolization steps under acidic conditions. The cross-conjugated enone can tautomerase toward a phenol, complete aromatization of ring A via sequential dehydration steps driven by the thermodynamic stability of the aromatic product. And for the final step, the bicyclic enone loses water or undergoes proton shifts to give a partially aromatic intermediate, ultimately yielding a product where ring A becomes aromatic, benzene ring, while ring B, the cyclohexane ring, retains the methyl group at the ring junction. The methyl group at the ring junction migrates or is retained as a substituent on the aromatic ring. The product is a tetrahydronaphthalene, tetralene, derivative with a hydroxyl group on the aromatic ring, specifically a methylated tetralol or methylated naphthol. The major product corresponds to option C, a bicyclic compound with an aromatic ring bearing a methyl substituent and a hydroxyl group on the saturated ring. This is consistent with 2-methyl-5,6,7,8 tetrahydro-2-naphthol type structure. The octalone aromatizes ring A under acidic conditions to give a phenol, with the methyl at C8 ending up as a ring substituent, and the resulting compound matches structure C. Option A, a monocyclic benzyl alcohol. The ring system cannot open under these mild acidic conditions. Option B shows a fully saturated bicyclic alcohol without aromatization, which is not favored. The thermodynamic driving force pushes toward the aromatic phenol. Option D, a fully saturated decalin with 2 methyls, no aromatization or hydroxyl, inconsistent with the enone starting material under acidic conditions. Therefore, the correct answer is C. Therefore, the correct answer is option C.